perfection from HTTP. It's basically about bypassing regex and all that, but we'll get into that very soon. All right, so I think we can begin. So I'm just going to share my screen and then we can start. All right, I hope you guys can see my screen.
Yes, Maxam.
All right. So as usual, first off, we just start the box, but then I've already done that. So we start off by doing our.
So before you continue, I don't know if someone here that's new to Hack the Boss, so can you give an overview of, because this is the first time in our session you're using Hack the Boss, something
Okay.
about the site so that people can catch up. Thank you.
All right, sure. So today we'll be solving a box on Hack the Box platform. Now, Hack the Box is a platform that provides like vulnerable machines. You understand? So they build machines and intentionally place vulnerabilities there so that we hackers can exploit and then build our skill with. Yeah. As ethical hackers, we can't just go about testing people's systems and trying to improve our skill. So Hack the Box is a platform that provides us with machines like that we are authorized to hack. Yeah, and then train our skill so that it can help us during penetration tests, ratings, and all that. Yeah, so that's about it for Hack the Box. You can just sign up on Hack the Box and then you can start spawning machines. So basically, they have a paid subscription, but for most of the boxes, or like for some of the boxes, you can still get them for free. You can still play them for free. All right. So today, the box we're going to be looking at is Perfection, right? And this is one of the free boxes on Hack the Box. So, as usual, when we log into Hack the Box and we start a machine, they'll give us an IP address, and then we start our enumeration and to see how we can get into the box or gain foothold on the box. All right, so we have our IP over here. So the first thing I'm going to do is to ping the IP and see whether it's alive. All right. I hope you guys can see my terminal.
Yes, we can.
All right, so I'm pinging the box, and then right now we are getting what replies, which means that the box is live. Okay. So most of the time we'll do an nmap scan, and my favorite flags to use when I'm doing an nmap scan is. So I'm just going to do nmap minus sv for service detection, minus sc for script scanning, and then minus vvv for verbals. Then the IP address comes, minus on to save it to a file, and then maybe I'm going to name this perfection.nmap. Now this can take some time to run, so I've already run it. So if I cut perfection.nmap, you can see here. You can see the syntax I used to run it over here. All right, so upon running the scan, there are two ports that are open on this box. We have SSH and then we have HTTP open. Now, mostly when you are trying to hack a box, you want to go for the low-hanging fruits. Now, SSH, even though SSH can be vulnerable at times, but it's not very likely. So most of the time, that what we would like to go for first is HTTP, just to see what's running over there. Now, we all know that HTTP can be accessed from the browser, or you can communicate with HTTP, or using HTTP like from the browser, right? So once you have your IP, you just go to the browser and then you enter the IP in your browser and see what you can get on the page. All right, so we are greeted with a web application. So you can see that there's this application called a weighted grade calculator. It is a tool to calculate the total grade. All right, so normally I would just read through this to get a fair idea of what the application does, right? Over here looks like it's a grade calculator. All right, so we'll get to that later. But scrolling down, you can see that when you scroll down for most web pages, and you get to see the technology that was used to build it, right? That's in some cases, not all the time. In some cases, so over here you can see that it is being powered by WebRick 1.7.0. Now, if you Google WebRick, right, 1.7.0, you realize that it's an HTTP server toolkit for Ruby, right? So let me just pull up my notepad and then we'll note that down. So we have what WebRick. Let me see if I can increase this a bit. Okay, so I'm trying to increase the font size so you guys can see better. Why can't I? I hope you guys are following though. I really like feedback from you guys so that I know that um, I'm
Yeah,
not
we are
for something.
following.
You're following, okay. All right. Okay, yeah. Currently trying to increase the font over here. I think it should be around. Yeah, yes. Okay. All right. So where was I? I was speaking about WebRick, right? So we scroll down on the page and then we found that the page is being hosted by a server called WebRick, right? Now WebRick, when we Googled it, is an HTTP server for Ruby. So I'm just going to note that down. All right. So right now we know that what this particular application was possibly built with Ruby because we googled WebRick and then we found that out. Now, scrolling through or going through the pages, right? Clicking buttons and then reading or basically browsing the web application. There's this about us button. I scrolled through this, but there was nothing really interesting over here. And then there's another one that says calculate your weighted grid. So you can also navigate to that side and see what's there. Right, so it looks over here. It looks like you can enter some data, and then I think it will calculate your weighted grade for you. So that's what is the application is basically doing over here. All right. So one way of browsing through the web application is clicking through this and seeing what is on the application, or just basically browsing through it. Another way to do it is that you can view the page source, right? And then maybe from the page source, you can try to see what is like behind the page and the kind of links that you can visit on the page. So over here, we have the about page, we have weighted grid. Like you can basically scroll through this and see what's happening over here. Another thing I like to do is that I also inspect elements and then I go to the debugger. Now under the debugger, you can basically see what was used to build the page. For example, if it's the page uses a CSS file, you would see that over here. For this particular page, you can only see the about page over here. And I'm thinking that from this, I'm thinking that maybe the website could be using inline CSS, or it could be pulling. All right, let me reload this and see something. Normally, you should see the files that I used to like build a website over here, like CSS files, JavaScript files, and all that. Yeah. So this is another thing that I like to do. I just like to come here and then look at what the application needs, or the kind of files is pulling. Sometimes if there are JavaScript files that I used to do some manipulation, you will see that over here. All right. So that's just by the way. So moving to the calculate your grid, your weighted grid side. That's where we have something interesting. So we are going to explore that side and see what we can do. All right. Any questions up to this point? Is there any question that you guys want to ask up to this point? Or should I proceed?
I think I can proceed if that's okay with everyone.
All right. Is everyone okay?
I think so.
All right. So over here we have a weighted grid calculator. Let's just test it normally and see what it does. So I think it first asks for a category. For now, we can assume that maybe that's a name of a particular course you are taking or something. So I can see this is maybe math, and I can see maybe I had 78 in math.
Okay. Please, can you go back to where are the debugging? I want to see it clear.
You want to see it clear?
Yeah.
All right.
The inspect elements and debugging.
All right. So that was just by the way. I was saying that like normally I like to inspect and then go to the debugger. Now, if you are using a different browser, it could appear differently. And I was saying that over here, you basically have the sources for the page, like the various files that were used to build the page. So in most cases, you come here and then you find JavaScript files and all that over here. Yeah, that's what I said about this. I hope you're okay. Are you fine?
Yeah, I'm okay now.
Okay. All right. So we can proceed. So it says it's a weighted grade calculator. We're speaking about entering some values in here and then testing the web application. But before that, let's just do a little reading because it looks like there's a description of what the web application does over here. It says, please enter a maximum of 5 category names. A maximum of 5 category names. It says your grade in them out of 100. I think this is bad English here. I think this is supposed to be you grade in them out of 100, and then their weights. And then it says enter null and void, right? This sign is for null and void. It represents null and void into a category that has into a category field, and then 0 into the grade and the weight fields if you are not using a row. Okay. So what it's saying over here is that if you are not using some particular row, right, we can just enter any or null and void, and then we can enter 0 and then another 0 here. That is if you are not using some particular row, right? I'm getting some feedback. If yeah, if your mic is on, can you mute?
Ben,
Hello.
please can you do us Anna and mute yourself? Thank you very much. Then we can proceed.
Okay, so where was I?
Yeah, the NA. So trying to create a now column.
All right. So it says we should enter a maximum of 5 category names, right? And then it's asking us to enter the grade out of 100, and then we are supposed to enter the weight too, right? Now I'm going to enter some values, and then we'll see what we get. So over here, I'll enter math here. The grade I'll enter maybe 78, and then the weight I'll enter maybe 9, and then it doesn't really matter the text we put in the category. We are just testing the application, right? So then just say 54. You see, I'm a very bad science student, so I had 24% in science. The weighted grade is maybe 6, and let's see RME. I'm very good at RME, so I had 98, and then the weighted grade is 8. All right, so now after entering this input, we can send it off with the submit button and see what the application gives us. All right.
Yeah, this will give you an error because your weighted column has to be added up to 100 exactly. So you split
Exactly.
into 10%, 20%, or whatever.
Exactly. So I was just, you understand, like that information wasn't given to me earlier on. So like we are currently testing the application to see what we can find. All right. So it was actually intentional because I wanted to see, I wanted to see what the application will tell me. And over here, giving me an error. It says what?
Okay.
Please re-enter weights. Please re-enter weights do not add up to 100. All right, so that's information we can keep at the back of our heads, right? It says the weights don't add up to 100, so what we need to enter weights that add up to 100. So I'm trying to approach this from a perspective where I don't know anything about the web application, right? So I'm going to enter math again. I'm entering the grade to maybe 87. The weights, let's make it 20. All right, so now we know that the weights have to sum up to 100. And then science, let's see, 67. And then let's also give this 20. Let's give this 10. Let's give this 30. And this 20. Okay, so let's see, let's see, this is RME, social, let's see, French. All right, so I'm just going to enter some Wait. All right. So upon clicking submit, I'm going to see what the web application is going to tell me. Right now, I feel like I'm confident about all the conditions, and I think it should give me some sensible outputs right now. So we have our weight to be 20. So all this, I think, sums up to be 100. So we are meeting the conditions. Let's see what happens. Okay, so it was able to calculate total grade for us, and then it's calculated what I think the weights for each individual subject, and then it gave us our total grade. Now we've been able to see how the web application works. So normally when you want to play around with the web application, right, you want to play around with its input and all that. It's a bit difficult to do it here because you need to keep re-entering values, and it makes it like really stressful to like keep re-entering values and all that. So we would employ a tool called BebSuite, right? So I'm going to use BebSuite. And what BebSuite is if I begin, what BebSuite is that it's a proxy, right? And what I mean by a proxy is that it's like it's an application that sits between the client and the server. So anytime you visit an application, you are the client, and then the server is somewhere else, right? When you request something from the server, your request goes to the server. But what BEP does is that it sits between the client and then the server. So when you send a request, it hits BEP first, right? And then BEP will forward that request to the server. So that is what basically a proxy is, right? It sits between the client and then the server. Now, one advantage about these proxies is that when we capture the request, or when like we intercept the request between the client and the server, we can manipulate the request, and then we can do several things to the request. So basically, that's what the BEP is helping us to do. Now, if you want to know the installation for BEP and all that, you can look it up online. But over here, I have BEP and everything set up. So I'm just going to select BEP. It's running on port 882, and I'm going to open my BEP, and then let me just move this. Let me just move this here, right? Okay. Okay, so we have BEP running here. I'm going to change my port to 8082 because, right, and then I think we get some incoming data. So you can see BEP is intercepting a connection that the browser was trying to make, right? But I'm only interested in the one that is coming from Hack the Box, or the machine I'm trying to hack, right? So let me just turn this off. Then let me just enter anything here. Then what I'll do is that I'll intercept the request, and then see what it looks like in BEP. Okay, so 10, let's say 10, 20, 20, 30, 89, 90.
I've realized that when I was working on this box, do you see the category column? When you enter maybe something that looks like a malicious code or script, it spells that information out too. So that's something that I also took note of. Let's assume you send in a cross-site script, send maybe just a script tag with something in there. It tells you this column is malicious. This is malicious. So you get to know, okay, whatever you sent in, it's not right. The system is not accepting that. So you get more information about how it's working.
Yeah. But I wanted to do that in BEP.
Okay, that's fine.
Yeah, I wanted to do that in BEP. I'm going to get to that like very soon.
Okay.
And I'm going to even speak about how the application is able to filter your inputs. But I just want to take it step by step so that those who are listening can follow like the methodology I'm using to pound the box. All right, so I'm going to submit my request, and then stuff. Okay, my intercept was
Just
off.
off.
Yeah, this thing can be very annoying. Let me just disable it and then let's do that again. Um, you see, that is why it is even good to test with BEP, because with BEP I wouldn't have to re-enter the values again. You would
Yeah.
see in a very short while.
Just reuse a request.
Yeah. But as I do it, are there any questions?
I'm
I
okay
don't.
with it.
Okay, like feel free to ask any question. Like if I'm doing something that you think you've never seen before or you don't understand, you can just let me know. Okay. So it's actually catching a lot of requests I'm making for my browser, but this is the particular request I'm interested in. Now, one amazing thing about BEP is that you can send this particular request the repeater tab, where you can manipulate it and then play around with the parameters and stuff. Now, anytime you send a request from your browser, an HTTP request, this is basically what it looks like. There are various parts of the HTTP request. You can read about that later. But then this is what the request looks like, and these are the inputs that we give the web application. All right. So upon seeing this, we can just send a request and see what it looks like in web. Um, when I scroll down, you realize that it's basically the same thing we're seeing on the web application. We have our total grade is for 93%. We have the various categories over here. All right. So now when I see something like this, and I'm seeing that it's being run by Ruby, right? One of the things I like to think of, one of the things I think of is SSTI. Now I'm going to get to that later. I'm going to get to that later. Another thing I wanted to show you guys is that sometimes when I'm testing a web application, I like to just do stuff that will make the web application throw errors, right? So I just entered an invalid path over here and you see it's throwing an error. And now sometimes when it throws an error like this, it gives you information about the web application, right? So it says that Sinatra doesn't know this DT. All right. So what exactly is Sinatra? Yeah. So with that, we can also Google and then we can say it's Ruby Sinatra, and then we basically get information about what Sinatra is. You understand? So previously, I discovered that it was using an HTTP server called Webbrick. And then now I'm seeing another thing called Sinatra, right? So it says Sinatra is a free and open source software web application library that is written in Ruby. So basically, what it is that it is like a web application framework that is used to build apps in Ruby, right? And Webbrick is an HTTP server that is used to host Sinatra web applications, right? So basically, that is what it is. Now, when I see an application like this, right, and I see that it's doing some mathematical calculations, and then it's returning the same page, one thing that comes into my head is that the website probably has a template that it just keeps doing some operations and then using that same template, right? So one thing that comes into my head is what SSTI or server-side template injection. All right. With SST, I can't speak much about it over here because if I'm to talk about it, it will take too much time. And we need to finish this within an hour. So I can't speak about SSTI, but you can look up what SSTI is. SSTI is basically a vulnerability that allows us to inject code into a template and then run that code, right? Now, injecting the code, we can inject maybe malicious code, and that would help us to be able to get like or run or execute code on the server. Now, when you hear something like that, immediately you know that okay, once we can inject code on the server or we can run code on the server, it means that we can perform a whole lot of actions, right? You can do a whole lot of things. So what I like to do is, I said SSTI came to my mind, so I'm just going to Google Ruby SSTI. Now, from the recon we already did, we know that the web app is what was coded using Ruby, right? So we can narrow down our search. So instead of just searching for SSTI, we know that maybe it's SSTI that has to do with Ruby. So the first link that comes up is Hacktricks. Now Hacktricks website is a very interesting website, very cool website. It gives you a whole lot of snippets to exploit web applications and a whole lot of things. So if you are doing recon or anything, it's always good to look it up on Hacktricks. They probably have something very interesting for you here. All right, so they are talking about SSTI in different applications, but I'm interested in the one that is with Ruby, right? You see, there's Java SSTI, like there are a whole lot of them, and even with the SSTI, like some particular SSTI, it's not the SSTI is not just SSTI in general, right? We are looking at SSTI in some application or web application framework. So if you pick a language like Ruby, right? Ruby has like different web application frameworks, and we are looking at what a particular web application SSTI in a particular web application framework, right? So over here I'm scrolling too much. I just want to look for where Ruby is. I'm just going to use the find command to do that. So I'm just going to say Ruby. Okay. Over here we have ERB. So that's the templating engine for Ruby, right? ERB is the templating engine for Ruby. And then these are the SSTI payloads. Now it says that this payload is, the website is telling us that if we enter this payload, we should get 49 as the output, right? So I'm just going to copy this payload off and then test it and see whether it actually executes on the server. So I'm just going to add it as one of the inputs for the categories and let's see what happens.
Sharon, I think you should check your internet because I can see from this end. All right, thank you very much.
I hope you guys can hear me. Hello?
Yeah, I can hear you. I can hear you.
All right. So I just put in some SSTI payload. That is over here. That is this over here. I don't know if I can increase the font over here for Beb because it's pretty small.
Your web sheet is not even in full screen. Make it full and let's see.
Right.
Yeah.
I'm seeing if I can make this really large. I managed to make the actual text large, but the request is what's the problem. All right, let's proceed.
Sharon, can you see now?
So I entered some SSTI payload, right? This is what it looks like. Now, before, just a second, let me just explain something. So if you look down here, this is what my SSTI payload looks like, right? But when you are sending a request, you need to encode it. You need to URL encode it so that like you can send it properly to the web application, right? You need to encode the text. Now, when you are transmitting information, it's necessary that you encode it so that you can transmit it easily, and whatever application that is receiving that request can understand it. So I'll just pick this payload and then I'll encode it. I'll URL encode it even before sending it. So I'm entering it in this particular category, and then I'm going to encode the payload. Please, I hope everyone is following. If there are any questions, you can ask me. All right, so I'm just going to allow some time for questions. If there are any questions, you can ask. Right, I believe there are no questions. I'm going to send in this request and then we'll see what we have at the outputs. So it says what malicious inputs blocked. All right. So it's telling us what we entered malicious inputs, and it's being blocked by the web application. Um. So when I see something like this, what comes into my mind is that they are using something called regex. Now regex is like code that is used to check input parameters, right? In web applications and a whole lot of web regex can be used for a whole lot of things, but it's normally used for filtering and then checking inputs, user inputs, yes, to be specific. So normally when you want to control user input, you don't want to make sure that the user doesn't input anything malicious. You would use regex, right? Now with regex is used to, as I said, regex is used to check what the inputs, right? So over here, what is happening is that they are using regex to check our input and see whether we are entering anything malicious. And I'm going to speak about regex shortly, and I'm going to explain to you why it's even blocking our input. All right. But for now, we can see that we are being blocked. It says malicious inputs blocked. So I'm going to speak about what the regex is doing. I have a code sample over here. I'm going to show you so you understand it better. So my file is called test.rb. Okay, so now this is code in Ruby, and this is what came into my mind. Like when I saw the web application that they are using regex to probably do some checks, right? Over here you can see they are checking if the input matches this particular string over here. Now what this particular string over here is, it's regex. No, so when you see the string over here, it's actually regex. What's happening is that it's saying that check that particular line from the beginning to end and see whether that particular line contains 0 to 9 and A to Z. Now, if that line does not contain 0 to 9 or A to Z, then flag it as what malicious inputs detected. All right. So that's what we are seeing over here. So it's first taking the input and then doing this check on it. Right. So this is our input, right? So this is what we inputted into the web application. We inputted something like this. This is basically just a second. This is basically our SSTI payload. Let me just increase this a bit. All right. So you see what I've highlighted here? That's the SSTI payload, right? And then it's doing a check on it to see whether it matches this particular regex condition. All right. So it looks like what the web application developer is doing is that the web application developer is checking the line. So he's just looking for alphanumeric inputs, right? So if you enter something that is not alphanumeric, the web application will complain and say what malicious inputs detected, right? So I'm going to run this code. Now you see what we have over here. We have ABC and then we have our payload over here. Now you realize that the greater than and then the percentage sign equal to are all not alphanumeric characters, right? So it should actually say it should say malicious inputs were detected. So I'm going to run this with the Ruby, and then when I run test.rb, you realize that it says what malicious inputs detected. All right, so I'm going to edit this a bit and let's see whether it matches, and let's see whether we get a match. So right now it's only ABC that I'm checking. Now ABC is what alphanumeric, right? And then I'm going to run this with Ruby. So test.rb, and then it says what good inputs. Let's continue. So you understand what is happening on the web application. What is happening is that like the web developer is sanitizing the inputs and checking for certain characters inside the input. If those characters are present, it would say what malicious input. I can test with another character. Maybe I can put an exclamation sign over here, and then we test and see whether that works. It says what malicious input detected because the exclamation mark doesn't fall between 0 to 9 and then
Hassan,
8 to 0. Yeah, hello.
you have a question, I guess.
Yes.
All right.
So is this code just an illustration of how regex works?
Exactly. Yeah, it's an illustration for you to understand what is going on at the back end.
Okay.
Yeah.
Thank you.
So this is just an illustration. I'm trying to explain to you what is happening. right, so I put an exclamation mark over here, and then you realize that it's flagged it and said malicious input. All right. So I'm going to test with alphanumeric characters, and we'll check whether it's good input. When I do that, it says good input. Let's continue. So which means that this is what good input, and then from our input, we can actually tell that that is good input. Now, one thing about this regex syntax is that, and one vulnerability with this thing is that it's just checking a line. You understand? So it's just checking a line to see whether there are matches in that particular line, which means that if we should add a new line, it won't do that particular check on that new line that we've added. So this particular check is just checking one line. You understand? So if the inputs that we send is multi-line, like several lines, they won't be able to detect the ones on that on different lines because it just does a check for the first line. Now in programming, there's an escape, or there's a character called the line feed. I just got to know about that today. I normally call it the new line character, right? So this is what the new line character looks like. This is what it looks like, /n. And when you are programming, this basically denotes that you want to start writing on a new line, right? So I'm just going to do some small demonstration for you to understand the new line character properly. So you see what's happening over here. I typed in hello, hi, and then I put the new line character there. Then I typed in hello, I put the new line character there, and I put hi. Realize that hi gets printed on a new line. You understand? So we are going to take advantage of this particular thing, right? And then we'll see whether we are able to bypass that particular check, that particular regex check over there. So I've entered my new line character over here, and then I'm going to put an exclamation mark here. I'm going to put an exclamation mark here. Now let's see whether it bypasses it, because we are only looking for alphanumeric characters. Now let's check if this would bypass. So I'm going to run with. You see, it's actually able to bypass it. It says good inputs. Let's continue. So right from this, we can infer that it's just doing a check on one line and not the second line, right? So this particular character is what is helping us to bypass that check. Now we can apply the same logic to the web application, right? So before we enter our malicious input, we'll put a new line character there so that it doesn't check our malicious input. It just runs the code, right? So we are going to put our malicious input over here. I think it's also % equal to 7 stars 7, yes, 7 stars 7, and then percentage. All right, so I'm going to run this again, and then we'll see whether it bypasses the check. All right, you see it bypasses the check again. All right, so now we can apply this knowledge on our web application, and then see whether we can get code execution. So this is our payload over here. Let me just copy it. Okay. I'm just going to copy this payload, this SSTI payload, and I'm going to open Notepad. Now this is what the payload looks like, but this is encoded actually. So what I'm going to do is that I'm going to insert a new line character before the payload, right? So our normal category name would be something like this name, and then I insert a new line character over here. Now the websites, as I said before, right? Whenever we are sending a request, like we need to encode it in such a way that the web application can understand what we want to send to it. So even with a new line character, we would have to encode it. Now the encoding for a new line character is the URL encoding for a new line character is %OA, and that's That makes it, or that will get decoded into the new line character. So I'm going to copy this, and this is this is the payload we will be using on the web application. I'll paste this over here, and then we send the request and see what gets printed out.
Okay, please.
Now,
Now say
if you
something.
look, hello,
Yeah, I want to say something.
okay,
Please, you're not supposed to. It's not a must for you to know all the encoded characters in your head. You can just encode in here. So he just knows it off here. That's why he just made it into the payload at once. So please, you're not supposed to memorize all the encoded characters in your head. Thank you.
okay, all right. Thank you for that. Um, so where was I? All right, so I've encoded that character, and then we have a payload over here. Now, our original payload is 7 times 7, which is supposed to give us 49, right? So it's actually doing a mathematical operation over here. 7 times 7 should give us 49. So when we enter this into the web application, it should run our code, and then we see 49 in the response, right? So I'm going to send this request, and then let's see what we have in the response. So I'm scrolling down, and you see, you see what's happening over here. If you look at this place, you realize that we have name, and then we have 49 right under name. So it introduced a new line character and then brought 49 over there. And then since we have 49, we know that what the web application is what executing code, or it's running code, right?
And
So
Sam, we
it's
have a
running
question.
yeah.
There's a question in the chat. How did you know which payload to use?
How did I know which payload to use?
Yes.
All right. So when I began, right, I did some reconnaissance. I was able to identify that the web application was using Ruby, right? And then I did some further reconnaissance. I realized that it was using Sinatra. So from the way the web application was working, I inferred that maybe uh, it could be using templates and stuff for the calculation and then the displaying of the page and all that. So I look for SSTI that relates to Ruby, right? I look for SSTI in Ruby, the language Ruby, right? You understand? And then upon doing that search, I came up across this particular payload, and that is what I'm using over here. I hope your question is answered. I hope your question is answered.
Yeah, I think she said yes.
Okay. Okay, so right now we are having 49. Now, this is not okay, this is just a proof of concept that like that our code is actually getting executed on the server 7 times 7, and we are getting 49. What we are interested in is actually getting access to that machine. Now, since this one works, it means that we can execute Ruby code on the server. Like we can write our own Ruby code, and then it will get executed on the server, right? So let's go back to Hacktricks, and I think they have some payloads that can be used to. They have some payloads that can be used to get code execution. Okay, so there's this payload over here that is used to execute code. You can see it's even written by it over here. It says execute code. I'm going to try this payload, and then we'll try to execute code on the server, right? So I'm going to go back to BEP. I'll clear the previous payload that I was using ends here, and I'll paste in the new one. Okay, so as usual, I have to encode it. To put it in a proper format, and then I'm going to send this off. Okay. So I think what is happening here is that the code is getting executed, but it's just returning whether it's worked or not. So it's returning a true over here instead of actually giving us outputs. So I think this particular kind of code execution isn't really visible. I think it's more like a blind code execution, because it's just returning whether the code got run or not. So it says true over here. So I think this is a blind code execution. So we know that the code execution works, right? Now we need code that will be able to get us access to the machine, right? And I like to use this website called revshells.com.
Popular way to go.
before I even use a payload, if you, I think before I use this payload, upon doing my nmap scan and stuff, I realized there was a Linux machine, right? So it means I have to use a Linux payload, a code that can be run on a Linux machine or a Linux box to get code execution. I normally like to go with this payload, so I'm going to use this. Um, if you don't really know about ref shells, you can read about it, but it's just a way for us to gain access to the machine. I'm just going to look at my IP address, and I'll use that to construct the payload. Right. So I'm just going to copy this. Then I'll go to BEP. Then I replace this who am I. So this who am I that you're seeing over here, it's actually a Linux command. So I'm going to replace it with a commander to actually get a commander to give us access to the box. Right. And I'll encode this so it doesn't give us errors. I'm going to encode this. Then I'm going to start my netcat listener. So I'll listener 8989. Then I send in the request. Now when I send in the request, the code gets executed on the server, and then I'll get a shell, right? So right here we come back and I have a shell. So I have user on the system. Okay, so right now I have access to the system, right? Normally what I like to do is that even when I get access to the system, I like to look around. So you can see that we are able to get access to the web application. So we are inside the Ruby app directory. You can see we got access to the Ruby application. So we are inside the Ruby app directory. We have the various files that were used to build the application here. We have main.rb. That is the file that was used to, or that's the file that is used to build the application. Normally, I like to just copy it over to my machine to just look at it later. But then browsing to the web application. All right. So browsing to the web application, we can see a whole lot of files over here. Let me just reduce this a bit. This is too large. I hope you guys can still see though.
Yeah.
Okay. So I'm just going through the server, right? The machine I just got access to. There are a whole lot of files on it. There's linpiece.sh over here, and I suspect that, like, because this is a machine on HTTP, there's someone also trying it, and the person just dropped linpiece on the server, right? So that's just by the way. But we have a user.txt over here. We have a user.txt over here. You can go ahead and cut it, and then you can paste it in HTTP, and then you have what you've been able to get the points for the user flag. All right. Now, by looking through all this, we have the bash history file, we have bash logout, we have a whole lot of files over here. But one interesting one is this migration directory over here. So I'm going to go into the migration directory and see what's over there. Okay, there's something really interesting here. It says what pupils credentials.db. Pupil path credentials.db. When you see something like this with an extension.db, it's most likely an SQLite database. You can look up what SQLite is. But I've worked with something like this before, so I know what it is. So this is an SQLite database. We can basically look through this database and see what's inside. So now the application needed to open this and browse through it. I don't think it's installed on this machine, so I'm going to transfer it to my host machine, right? And then I'll look through and see what's inside. Now, luckily, we have read access to this file, which means that we can copy it from this machine. Normally, I like to use Netcat to copy files. So let me just increase this a bit. So I'm just going to I'm going to listen on 1990. So over here, I'm just trying to copy a file, right? and then whatever data it gets, it should output it to, let me just call this test.db. Then I start listening. Over here, what I can also do is that I can connect to my local machine. What was my IP again? Let me check it again. Or is it still on my clipboard? Oh no, it isn't. Alright. So I'm just going to do an ifconfig times 0. I'm going to copy the IP again. Let's close this. Okay. 1990. Let me just copy this. I don't want to type it out. Alright. So upon hitting enter, it will basically read this file and then forward it through netcast to my host machine. I could actually go into this and explain why this is working, but it will just take up a lot of time. So I'll just wait for a while. Now the disadvantage about this is that you never know whether the file got copied fully. That's the only disadvantage. But what I like to do is that I just wait for a while. I'm really patient. So I'll just wait for a while. And then after a while, I just close the connection. And then I do an LSLE on the file test.db. You can see the size over here is 8192. I'm going to do the same on the server and see whether we have the same size. All right, so we have 8192, which means that I've copied the full file successfully. That's good. Okay, so I'm going to use an application called SQLite to browse through this database. Oh, I think it's SQLite 3. All right. So there are various commands that you can use to browse to an SQLite database. First of all, I'm going to look at the tables that we have inside this SQLite database. We have the users table, right? I'm going to write SQL syntax to read data from the users table. Now, I only know this because I've worked with SQL before. That's why I'm able to write these queries from off the top of my head, right? But if you don't know SQL, you can just look it up, or if you don't know SQLite, you can just look it up. I think even before getting to this part, let me just explain something. You can run file on the file that you just copied and then get information about that particular file. So when I run file on this, you can see that it's telling me that it's an SQLite 3.x database, right? So from this information, you can just do a Google search and see how you can browse through SQLite databases, right? So I'm going to go back to where we were. The tables will show me the tables that we have over here. We have the users table. I'm going to select star from users. And then we have some very interesting stuff over here. We have Susan Miller, and I suspect that this is a password. There's a way to use SQLite to see the various column names, but I'm not going to cover that for now. All right, but what's happening here is that we have the user ID here, right? The 1, 2, 3, 4. That's the user ID. We have the name of the user over here. We have Susan Miller. And then we have Susan Miller's password, right? Susan Miller's password. Okay. So right now we have Susan Miller's password hash. Now, even though we have the hash, we still don't have the plain text password, so we can't do anything with it, right? So best case scenario is that we crack this hash and see whether we can actually use to log, or we can actually use to gain access, or we can actually use to log on to Susan Miller's account. Funny enough, we are already Susan. So I suspect that this particular Susan is the Susan Miller in the database. All right. So that's just by the way. Now let's continue doing some other enumeration on the box. Now many people would like to run learn piece at this stage, but what I like to do is that just to browse around and see what I can find on the machine. Right? I don't know. I think the thing has frozen. It looks like there are a lot of people playing this box.
Hmm.
Oh, I just lost connection. I just lost connection. No problem. Let's do that again. I'm going to send a request again. Okay. So before I run limp piece, I just like to look around on the box and see what's available for us to abuse and get root privileges. We just found this database with a password inside, right? One thing I like to do is to look for SUID bits, and you can do that using this command. Use S I F F now. Now, if you take your time, you can actually understand what this command is doing, but I'm not going to explain that for now. But basically, what it's doing is that it's finding SUID bits. So they are basically programs on the PC that get to run as the root user. So if we find an SUID bit that is vulnerable, we can exploit it to gain root access. But looking at all these SUIDs over here, I don't think any of them, like from experience, I don't think any of them can be used to gain root privileges currently on the box. Another thing I like to do is just look around, right? Um, for the sake of time, I'm just going to go straight to the point. I like to also look at the mail directory, right? Now, looking at the mail directory, we have a particular file in it, right? And luckily we have read access to that file. So the mail directory is like basically mails that were sent to that particular user. So I'm going to read the mail directory. Maybe we might find information about that particular user or some information about this information on the system, right? So I'm going to cut because it's a file, right? This is a file, actually. I'm going to cut that file and see what we have inside that file. Oh, this is taking a while. Okay, so let's read what's over here. It says, due to our transition to Jupyter grades because of pupil path data breach, I thought we should migrate our credentials, including the students in our class. This is just some random text. What's really important here is over here. It says the password format is first name backwards underscore randomly generated integer between 1 and 1 billion, right? So if you are going to crack this password, we actually have information about how the password is crafted, right? So that can help us to be able to crack the password faster. Because under normal circumstances, if you don't have any information about the password, it would take a very long time. All right, so going back over here, I'm interested in Susan's password mainly because there's another thing that we do when like we are trying to see the privilege escalation vectors. Like when we want to escalate to root, right? When we want to get access to the root user, there are certain things that we do. Like for example, this particular user, Susan, could be given access to run certain commands on the system as the root user. So normally you can use sudo tacl to do that. I know this is going to error out because of the kind of shell we are using. I think it says I should add -s. So I'm going to add -s and let's see what happens. Over it's asking me for the password of Susan. I don't know that currently. So what I'm going to do is I'm going to try to crack the password that we have. And then when I crack the password, I come and use it over here. Now the password cracking takes some time. So I've already cracked it. I already have it cracked. I don't know whether I kept it. But let's see. So this is the password hash, right? I'm going to save that to a file. And then I'll crack it with normal cracking tools. So I'm going to use Hashcat. Hashcat is like the world's fastest cracking tool. So I'm going to use Hashcat. And then I'm going to paste. So I'm going to just call this Susan dot hash. I already have a file like that, so I'm going to use hash1. Then I paste in the hash. So I know that this is Susan's hash, and I want to crack it. Now, before you can crack a hash, you need to know the type of algorithm that was used to hash the password, right? I think we spoke about hashing one time in the group. This is why we discuss this kind of concept too, so that you guys can understand like what is happening. Like maybe if you have sessions like this, or maybe if you yourself you're trying to pawn a box, you see something like this, you understand whatever is going on over here. You understand? One thing about hacking is that you can't just wake up and hack something you don't have knowledge about. So it's necessary that you do read it, like you read and we research about stuff so that you can understand the system you are trying to abuse. Okay, so over here we have the hash in the file. I'm going to use hashcards on the file to see the kind of hashing algorithm that is being used here. Let's just be patient. And the first result I get is SHA-2256. So this is basically SHA-256 algorithm, and then we can crack this with hashcards. Now, because we currently have knowledge about the password, we can actually we can craft the password, or we can actually limit the possibilities. You understand? We know that they said we know that the password is what basically the user's first name and the user's first name backwards. So Nasus underscore what's some value ranging from some random value ranging from 1 to 1 billion, right? Does anyone have any questions to this extent?
Jill, please can you mute yourself? Thank you.
Yeah, I have a question.
Yeah, please
Would
ask.
the hash cards work for maybe you are using Decrypt or Instructor or something like that?
They are making feedback in the background. I'm not
Michael,
really hearing.
please, can you take care of your mic? Thank you.
Nigeria's president has ordered security forces.
Yeah, please ask your question again.
I'm asking that can the hash card determine if maybe a hash is a decrypt hash or maybe a script hash or something?
Yeah, so you can see that I use hashcards to even guess the hash. So I use hashcards to guess the hash, and then the very first results came up as was SHA-256. So that's what I'm going to go with. You realize that it's guessed that it's also these hashes, but the highly possible one is the very first one. So that's what I'm going to go with. Right.
Okay.
Yeah.
Does the number in front of it represent anything? Before the name, see there's a number and
yeah, it represents it. So if you really want to use hashcards, you have to learn how it works, right? The number is actually the mode that we'll be using later on. All right. So what was I? So we have some information about the password, right? When we read the mail, we have some information about the password. It says what the password is what first name underscore first name backwards underscore some randomly generated integer between 1 and 1 billion. All right, so this is the first name. The first name of Susan. The first name backwards is what Nasus, and then what is over here is what we don't know, right? So this is the only thing that we have to guess, and we know that from the mail we know that the number ranges between 1 and 1 billion, right? We can use hashcards to do that. Now, hashcard has these rules and stuff we can use to crack this password. So I'm just going to copy this. We'll use it later on. So I think I have. Okay. All right. So from the mode, we saw that the mode was 1400. We supplied the hash Susan.hash1. Then we supplied the hash, and then we'll supply numbers ranging from 1 to 1 million, right? But then we have to first specify the attack mode. Hashcard has different attack modes. We are going to use its third attack mode, and then the password was of these formats: Susan Masses. Okay. So basically, these are the only things we don't know. These parts of it is what we don't know, right? So we can use %d to denote a digit. So you can do this percentage D. Now 1 million, how many characters does, how many digits does 1 million have? It has like 10 digits, right? 1 million has 10 digits. So I'm just going to do this 10 times. So because we want to guess the digits 10 times, right? Let me see if this is 10. 4, 6. Okay, so this is 10. So this is 10 characters, and then we are going to say increments. So it will first start from 0, then you keep incrementing till it gets to that stage. Right, so you can run this. I've already cracked it. That is why hashcat is telling me this. I've already cracked it, so I can just do /show, and then you will see the password over here. So this is the password for the Susan user. So now that we have the password, so in this case, I've already cracked it. That's why I have access to the password. But if you are doing it, you would have to actually wait for a while. It takes some time for hashcat to crack the password, right? So I'm going to come back to the machine and I'm going to try that password to see whether it works. So I'm going to do sudo minus L minus S, right? And it's asking me for the password. I'm going to paste the password here. Let's see if it works. And it works. So from the permissions, the sudo permissions for that particular Susan user, you realize that Susan can execute any command on the system as any user, right? So to escalate to root, you can just do sudo su root, and immediately we do this, we are root. So if I say who am I, you realize that we are root. Now to get a full shell, I'm just going to do Python. You don't have to worry about this. This is just a way to get the prompt. Okay, so you can see that we have the prompts now. So I'm going to move to the root directory where we can find our flag. Okay, we do it. And then you can see we have our root flag over here. So that is HTTP perfection for you. Any questions? Any questions? Or am I off? Hello? Hello? Are there any questions or any suggestions? Maybe I didn't do something properly. You want to suggest a better way to do it?
That was a good session. Please, does anyone have a question, contribution on something you don't understand? We are open to answer you.
Wow. Okay, someone has a question.
Michael.
Yeah, Michael, you can speak to us. Yeah, we are listening.
Michael, I think you've muted your audio.
Yeah, sorry. Yeah, hello. Sorry.
Yeah.
I was actually initially about like using the bcrypt. Is this like trying to, let's say we are on the part where like we are trying to protect our system, right?
Yeah.
And here like SHA-256 was easily cracked, not easily per se, but like we are looking for maybe a hashing algorithm that will be to take some time to crack. I don't know how long it took you to crack this one.
Yeah.
Like I was actually saying, in case of like have bcrypt, because usually like when you are watching maybe YouTube tutorials and they're showing you how to hash password, that they use bcrypt. So is bcrypt safe? I mean, in the sense of, like we saw like you cracked it here. So my question is like, do you recommend any kind of hashing algorithm when you are trying to hash a password or something on your end?
So yeah, there are some recommended password hashing algorithms. I think there's SHA-512 and all the other ones that actually take a longer time to crack. But the ideal thing is that you should actually put restrictions on the users to craft their password in such a way that it's actually not difficult to crack. So it's actually very difficult to crack. It's actually very difficult to crack because if you even use SHA-512 and someone uses 123 as their password, it still can be cracked within like a very short time. So more emphasis on like the password that you are trying to like put restrictions on the password that you are trying to crack. Now the only reason why with this one we are even able to crack it within a short amount of time is because we had information about the password, right? So the number of possibilities that we had to guess were reduced, right? You understand? So we only had to guess numbers between 1 and 1 billion, right? If you pick some passwords or if you pick some password hashes, right, it can take years to crack it. Like it can take a very long time because there are a lot of unknown things about the password. But once you have known information, once you know something or you have some information about the password, it makes it easier to crack. You understand? But I understand where you're coming from because there are some password hashing algorithms that are like very, very easy to crack. Like I wouldn't say easy to crack, but they are really fast algorithms. You understand? They have low cost. You understand? When I say low cost, like they are less system intensive, so they don't really require like very robust architecture. So a very robust machine to be able to hash those passwords. An example is MD5. MD5 is like really weak. You can crack MD5 or you can try a whole lot of words with MD5 in a very short time. But if you compare that to SHA-12, it will take you longer. So a password that's the same password that will be hashed in MD5 code can be cracked faster than the same password in SHA-526, right? So SHA-512, sorry.
Yeah,
Yeah,
that's
so
another suggestion.
yeah.
Okay,
So
I have a question.
but there's one thing I want to add. Okay, you ask your question. You can
Okay,
ask it.
well, we've looked at SCTI, we've looked at a couple of vulnerabilities in here. How do we remediate that? How do we mitigate all those kind of vulnerabilities?
Okay. So when it gets to SSTI, it all boils down to input sanitization, right? Any input that you take from the user has to be properly sanitized. Over here, you realize that the web developer tried to sanitize the inputs with regex, but the how he wrote the regex was like really bad. He didn't write the regex well, and that is what caused people to be able to the attacker to be able to bypass it. You understand? So when you talk of SSTI, you should avoid using in some language you have to avoid using dangerous functions, right? Like in Python Flask or Python Ginger, for instance, you have to avoid using the render template string function. You understand? And then you also have to be very careful of user inputs. That is what it boils down to. Like sanitize your user inputs properly because that's the only way the person can abuse the application. Once you are giving the user the chance to give the application some data, then the user can abuse it.
All right, thank you.
Yeah. I also wanted to mention something about hashing. Now, you may think that it's always it's always a good thing to really use very robust hashing algorithms. But the problem is that when you use very robust hashing algorithms, it also puts stress on your system, right? So, for example, you have an embedded system, right? You have an embedded system with very, very small system resources, but you want it to you want it to use a really strong hashing algorithm. You realize that it won't even be able to serve its purpose because it will use all its resources to just be hashing people's passwords. So that's one thing about strong algorithm. So you want to use maybe an algorithm that is not very system intensive, depending on the use case, right? Not very system intensive, doesn't use so much resources, and then you want to enforce that your users use very strong passwords. Yes. Yes, I think that's about it. Any
Okay.
questions?
Do we have any more questions for the evening? It seems we don't have any. Then, Maxam, I think we have.
I hope you guys enjoyed the session and hopefully.
Yeah, it was actually educative. And we learned a lot.
Okay, thank you. All right.
So
Um,
we'll see you next Wednesday, another session.
but before we go, I would like to ask: is anyone there here that would like to volunteer for the next session?
Yeah,
Like
that's very necessary.
just pick a machine and then you do it with us. It can be like it doesn't have to be like a very complex something. Like it could be a very simple THM machine. We can all learn something from it.
Okay, let's not forget, it's not supposed to be apparently a machine all the time. You can take a topic that you think you could explain to the community because you want to be doing a little bit of theoretical stuff so where people will understand the concept behind some things before we jump onto the boxes. So it's not a must for you to take a box. Maybe you have a topic or something that you've read about that you really want to explain this kind of vulnerability properly to the community. We realized that some people among us too are very new to this whole security stuff, so we had to do the groundbreaking works for them to understand the very basics so that when they come to the machines and we are doing this and that, they are able to catch up and understand what is going on. So please bear that in mind too.
Okay. Okay. Yeah. That's very true. So would any of you like to volunteer? Hey, no one wants to. No one wants to volunteer.
I beg, volunteer for what lah?
Volunteer to come and demonstrate or like come and explain some concept or talk about some particular concept in security or
Okay, I think there's something in the chat.
yeah.
Real world. No, please. The real world, we have a lot of boundaries to place. That one is left for the other side of the world. For now,
Yeah.
let's use a simulated environment. All right, thank you.
Okay. Okay, that would be wonderful. That would be wonderful. And then maybe we'll have Sharon there
Yeah,
after. Yeah.
yeah. After Clement, Sharon can help join the party.
Yeah. Sharon, you agree, right? If you are silent, it means you agree. Okay, so she agrees. Right, so we have Sharon next 2 weeks. All right, so I guess you can call it a day.
All right, well, have a nice evening. Enjoy the rest of the night.
Okay, bye.
If you're going to sleep, good night. Have a nice sleep. I'm ending the meeting for everyone.